Okay, so we'll start, and so today we're going to cover environments and object-oriented programming in R. And let's see if this goes. Okay. So let's talk about environments. I mentioned these briefly when I talked about scoping when referring to functions, but here we're going to kind of explore this topic a little bit more in depth. Okay, and so the environment is actually a data structure, and it's the data structure that powers scoping. The job of an environment is to associate, or what we call bind, a set of names to a set of values, right? So when you are working in R and you say something like store the value 3 in X, what you're doing is you are binding the name X to the value 3, okay? And so an environment is basically a bag of names, and then we bind those names to values. So every time we name something, so here we're creating an environment, and inside the environment we're taking the name A and we are binding it to the value false. Or here we are taking the name B and we're binding it to the character A. Or we're taking the name C and we're binding it to the value 2.3. Or in this case with D, we're binding it to the vector 1, 2, 3. Okay, so that's what we do with an environment. Okay, I'm taking these directly from Hadley Wickham's stuff on environments. He does covers it very well in his textbook, and so that's what we have. Okay, every environment has a parent environment. Okay, and so in diagrams we can have the pointer of the parent environment be this black dot here. Okay, and so this is the environment, and this environment over here would be the parent of this thing. Okay, and so everything has a parent environment, and it keeps going and it keeps looking to its parent until it reaches the topmost environment, and that's called the empty environment. Okay, so every environment keeps having a parent environment until it reaches the topmost environment, which is the empty environment. Okay, and so there are a few special environments. The global environment is your regular old workspace. When you start up R and you start working in R, you start assigning values in R and things of that nature. That is the global environment. Okay, and the parent of the global environment is the last package that you have attached to R. So whatever, as you load packages, you load ggplot, you load dplyr, or whatever, that package becomes the parent environment there. Okay, and that basically establishes the search path. Okay, the base environment is the environment of the base package. Okay, and the parent of the base environment is the empty environment, right? And the empty environment would be the ultimate ancestor of all environments and the only environment that doesn't have a parent. Okay, and the environment is the current environment. Okay, so search lists all the parents of the global environment. So this is called the search path, right? And so if you started up R right now, if you're in R, you can type in search, okay, and it will list off all of the environments that it's going to search. So it starts off in the global environment, and then when you load up R, kind of in the background it silently loads up all of these packages for you every single time you start up R, right? So it has package stats, package graphics, and it basically, when you type in a command like mean or standard deviation or something, you don't have a function called mean defined in the global environment, right? Your global environment, when you start up R, is generally empty, and so when you say I want to use the function mean, it's got to search for that, right? And so what it does is it goes to starting at the global environment, says I don't see the function mean, I'm going to search the parent environment, and it looks for it in package stats, and it keeps climbing it until it finds the function that you're looking for. Okay, either in package stats or package base or anything in between there. Okay, and then the base environment, its parent environment is the empty environment. Okay, so this is kind of what it looks like, right? So you've got the global environment, you've got all of those packages in between, and it keeps searching. If it doesn't find it in here, it searches the next one and it keeps going until it reaches the base environment, and then if if it doesn't find it there, it will go to the empty environment and it will just say, I didn't find it, right? So if you, let me start R over here. Okay, so if I ask for the function mean here, whoops, it's searched everything and it found it in the base environment. It will tell me that it exists in the base environment, right? And then that way I can run the function mean on some vector here, okay? But if I say what is D, okay? It basically, what it's doing, it's looking for the object D. It doesn't find it in the global environment. It keeps searching up the paths. It doesn't find it, reaches the empty environment and says, I didn't find D anywhere in there, right? The global environment right now is empty. I can define the value 3 here, and then so now when I call for D, it searches in the global environment and it finds it right there. All right, is that okay? Just kind of how it's searching up the path, the search path. It goes through all of these things, and so you can, if you're not sure, you can just ask search, and these are all the things that it loads. Okay, so RStudio, there's things there. Okay. Function environments. So when we are dealing with environments, probably the most important context in which this makes a difference is when we're dealing with functions. Okay, when we write a function, we execute a function, the environments play a big role. Okay, so a lot of environments, or most environments, are created as a consequence of using functions. Okay, and so we're going to look at the 4 types of environments associated with a function: the enclosing environment, the binding environment, execution, and calling environment. Okay, so the enclosing environment is the environment where the function was created. Okay, so every function has one and only one enclosing environment, and for the other types of environments, being binding, execution, and calling environments, there may be 0, 1, or many environments. 0, 1, or many. Okay, the binding a function to a name with kind of either equal sign or the assignment operator defines the binding environment. So the enclosing environment is where the function was created. The name defines the binding environment, and then calling a function creates a temporary execution environment that stores the variables while the function is running. Okay, and then every execution environment is associated with a calling environment, which tells you where the function itself was called. Okay, it sounds all funny. Okay, and we'll look at a diagram talking about what each of these environments are and whatnot. But probably the most important thing to know is that the execution environment is just a temporary environment for the variables when that function is running, and only when that function is running. Okay. So the enclosing and binding environments. Okay, when a function is created, it gains a reference to the environment where it was made. Okay, this is the enclosing environment and is used for lexical scoping. And then when you name a function, the environment where the name exists is the binding environment. Okay, in most scenarios, the enclosing environment and the binding environment is the same. So if I'm over here and I create a new script, and I say something like, we're going to create a function called myMean, okay? And what this is, it's a function of x, and what we're going to do is we're going to sum x, and we're going to divide by length of x, okay? And this is what it will return. So this, when I create this function, okay, so technically we can create this function and that's it, right? And can I execute this? I don't know if I can execute it like this. Maybe. No, I can't. So here I've created a function, and it's been made in the global environment, but I didn't assign it a name. So if as soon as I call it and I say this is my mean, then it was created in the global environment, and the name my mean is where the function is. The name my mean is bound to this function, and so this is the binding environment. So now I can run the function myMean on the vector 3, 4, and it will add them up and divide by 2. So now I have the function. It was created in the global environment, so its enclosing environment is the global environment, and the binding environment, because the name is in the is the binding environment. Okay. So here I've got a function, and I'm in the global environment. I'm going to create a value y. Here, let me just clear out the space. Okay. So y in the global environment, y is bound to the value 1. And then I'm going to create the function f, where I just add x to y. F is a function of x. All right, so I'm creating a function of x, and what we return is the value x plus y. And I can ask, what's the environment of f? And it will say the environment of f is the global environment. Okay, so f is created in the global environment, so that's the enclosing environment. Okay, the name f exists in the global environment, so that's also the binding environment. Okay. The distinction between enclosing and binding environments is important for package namespaces. Package namespaces keep packages independent. So for example, if package A uses the base mean function, what happens if package B creates its own mean function, right? So oftentimes it's not a good idea to create a new function that has the same name of another function, but it's also allowed, right? Or create a new variable, right? So I think a common mistake, this is where students get a little bit of trouble. A common mistake is, you're going along and you're calling variables, you decide to name variables different numbers, right? Or sorry, different values to different letters. So you say like A is 3, and B is 4, and C is 5, and D is 6, right? Can you see any potential problem with what I just did there? I said C is 5, right? So now I've created a variable, a variable called C. I bound the name C to the value 5. But C is a very important function that we use for the creation of vectors, right? So I use C to do something like, I want to create a vector, 3, 4, 5. Now, if I had come along and I said C is the value 5, and I tried to do this, R is smart, but later on, we could run into problems where, because R is smart enough to recognize that this is, here I'm asking for the function C and not the value C, but then if I create another function, like if we have something and I say function C is like we're going to do x plus 3 or something like that. And now I've done this, it's going to complain. Okay, so let me remove C here. Okay. So what do we do here? Okay, there's only a few restricted keywords in R. So you can't assign values to true, you can't assign a value to false. But mean, there's no rule against that. You want to create a new function called mean, that's allowed. Okay, the namespace ensures that package A continues to use the base mean function, and that package A is not affected by the mean function that was created in package B. Okay, so where you create your function and whatnot will kind of determine the functions that it uses. 99% of the time you don't have to worry about how this works, and it just does. But sometimes if you're creating things and you're a little bit sloppy with your naming, most of the time R is very forgiving, or it's smart enough. The rules that have been implemented help you avoid problems, but sometimes you run into problems. Yeah. Execution environments. Okay, so yeah, that's a good thing to know. Just I would not assign values to the variable C, or don't create a new function called C. That's asking for trouble. Okay, each time a function is called, a new environment is created to host execution. The parent of the execution environment is the enclosing environment of the function, and once the function has completed, the execution environment is thrown away. Okay, so here I'm creating a function called h, and inside h I'm creating the value, the variable a, and I'm assigning it or binding it to the value 2. And then what it returns is it's going to return x plus a, right? So all this does is basically it just adds the value 2 to whatever it is. So if I run h of 1, y is going to take on the value 3, right? Okay, when we execute, this is kind of the diagram that we get. Okay, so over here, okay, we're calling the function with x equal to 1, right? So we are calling it h of 1. Okay, and so when we do this, because in the argument list, this the 1 is in the position of x, it's creating an execution environment, okay, where x takes on the value 1. Okay, so this dotted line represents the execution environment. Okay, the function h exists in the global environment. Okay, and so this is the function. This is the naming environment, and then the enclosing environment, the parent environment of the function itself, is the global environment. Okay, so this execution environment, its parent environment is the global environment. Inside the execution environment, a is assigned the value 2. Okay, so inside the execution environment, in our names, we have two names now. X is assigned the value 1, a is assigned the value of 2. Okay, the function runs its operation, x plus a, and it says, okay, that's worth 3 now. Okay, and at the end of that, the result of the function, that result that's returned, is returned in the global environment, and saying we're going to take the result of that thing, which is 3, and assigning it to the value y. Okay, and so y gets assigned the value 3. Everything that was created in the execution environment goes away now. Okay, so this value of x and a, these disappear, and they are gone. And so now we are left with y has the value 3, and h still has the is assigned to the function, is bound to the function, and there's no other trace of X or A ever existing, right? So if I clear out my environment here, and I say h is a function of x, and a takes on the value 2, and what we're going to do is we're going to return x plus a. Okay, when I run h of 1, I have to create that. So inside my global environment, I have h. When I run that, I get 3. If I say take the result of that and assign it to y, then inside my global environment, I just have y and h, and there's no indication that x or a ever existed. Okay, because they never did exist in the global environment. They've only existed in the execution environment. Okay, and we can temporarily see this the execution environment if I save this. Script for 815. Okay, and I can set a breakpoint. Okay, I'll just set a breakpoint at each of these things, and we will source this. Okay, and so when I run this inside inside here, I can let's see, we will click continue. All right, and so now temporarily, okay, as I continue on inside the browser, we can see that the environment that I'm looking at, this is in the global environment. I have h and y, but I can step into the environment of the function h itself. And here I can see right now we have created x, x has the value of 1 inside the global environment. So I can say, okay, what is x, right? And then a has not yet been done. So I'll click kind of the next line here, okay? And here we can see, okay, now we are about to assign the value a, and I step into next, and is that not? I don't know why a did not get assigned a value here. Debug a is 2. Why is this? Okay, I'm not sure why. Oh, okay, sorry. I just had to hit next a few extra times. Now a has been assigned the value 2 inside the function, and I can see, okay, a takes on the value 2. We can see that, and as we are going, we are clicking next and next. I think I've just created too many breakpoints in my function here. Okay, and then it gets assigned the value 3, and then it disappears. So, you know, if you are curious what is happening inside the execution environment, and to see, you know, x get assigned the value 1 and a get assigned the value of 2, you can just create a breakpoint inside the function and somewhere in the script. You've got to save that script file, okay? And then all you do is you click kind of off to the side over here, and you say, this is where I want to set a breakpoint. And then when you run it, it runs it starts running the code, okay? And then you just kind of click next, and you can see line by line where these things are going, okay? Okay, so that is the execution environment. And again, if you keep in mind how our search path works, okay? Well, not necessarily the global environment, but if it doesn't find the value that it's looking for, it searches kind of the parent environment, right? So if let's say I create the value 3 up here, and I say x plus a plus b, and over here I say a is the value 4, okay? So in the global environment, I have a is the value 4, b is the value 3, okay? B is the value 3, and we're going to create this function, and we're going to kind of execute this. Let's create a breakpoint here, and we can see if this indeed works. Okay, so as I execute this, oops, sorry. Okay, so inside here, we can see x has been called with the function 1, okay? And then as I go to the next line, a takes on the value 2, and if we ask, what is b, okay, and what is a, we can see, okay, a has now been assigned 2, so when I search for a, it takes on the value 2, and then when I ask for what is b, it doesn't exist in this environment, so what it's doing is it's searching the parent environment, and it finds the value 3 in there. Okay, and then as it continues and runs, it will say, okay, I'm doing x is 1, a is 2, and b is 3, and we're going to add those together and return the value 6. So you can kind of just see where, keep that in mind when things are called. All right, so when you call a function, it creates an execution environment. The execution environment has two parent environments, okay? The enclosing environment and the calling environment, okay? If you created a function in the global environment, then the calling environment, which is where you are calling the function from, and the parent, enclosing environment, those are going to be the same. Those are both going to be the global environment. In some cases, you might call a function from inside another function, right? So, here I have got the function h. I could create another function called g, and this is a function of x, and what it does is it's going to call h of x from inside g and add the value 5 to it, or something like that, okay? So now h of x is a function that exists in the global environment. So its parent environment for h is the global environment. However, g is being called from over here, and so here let's complicate this up. And do this, okay? So inside here, so h is calling, it's going to return x plus a plus b. So if I ask for h of 1, it's going to say 1, a is 2, and b is 3 from the global environment, okay? Inside g of x, I'm saying b is 10, okay? And I'm asking for h of x plus b. So what is this going to return? Let's say I call g of 1. Is this going to, when I do this, is it going to return 16? Or is it going to return, what would it return? 2 plus 1 plus 13 plus 10, 23. Okay. So because H is inside H, it's asking for B, right? And so does the B here refer to this B, or does it refer to the B from G, or from where it was called? Okay, and so this is the difference between the calling environment and the enclosing environment, right? And so if I remember everything correctly, this will return 16, but we'll run this. Oops, now I got it. Let me stop this. Okay, let's just save this, and we'll clear everything out. So I got A, B, H, Y, G. Okay, so now I'm going to call G of 1, and it returns 16. Because when it's calling H here, and it runs this, and it looks at this B, the enclosing environment of this H is the global environment where B takes on the value 3. Okay, and so inside this function, it's going to run H of X, and it's going to reference this B, and return this thing is going to take on the value 6. And then it goes on and it says, oh, I want to add B, which is worth 10, and we're going to add that. And it gives me back 16. So do you guys see the difference between the calling environment and the enclosing environment for this? Okay, this is, these are like contrived examples, but sometimes as you're working on things, you're going to be calling functions from within other functions. That's a common thing to do, but you have to keep in mind, if you want to manipulate some values that are being referenced to from the function, it's going to be looking at the enclosing environment and not the calling environment. There is a possibility to have it reference the closing environment, and that's dynamic scoping, but I don't remember how to do that, okay? And I didn't write it, and I'd say it's less common. And the truth be told, it's a bad habit to write your programs this way, okay? But rather than just crashing and saying, you wrote sloppy code, I'm not going to do it, R is going to do its best, okay? But you need to understand kind of the rules and that it's following here, okay? What you should be doing is every value that's being used inside the function should be passed to it. So H should technically be a function of X, A, and B, okay? You want to give it these functions, or give it these values, so that when you are referencing X, A, and B inside the function, there's no ambiguity about where these values are coming from. That's kind of best practice. But sometimes we're lazy and we write sloppy code, or maybe not even because we're lazy, we're just maybe not super skilled and we write sloppy code, and so this is how R is going to behave. But what you should be doing is every value inside the function, ideally you passed to it as an argument, okay? And yes, that means you got to do some more typing when you call the function, but then there's no ambiguity about what values those things take on, okay? I'm going to just pause for a second here. So we're going to have a midterm exam a week from Thursday. So that's third week Thursday. You've got a midterm exam, right? I mean, that's like half of the course, right? And it's going to be very, very focused on R syntax and kind of these R rules. And I'm going to and it's going to basically be like, I'm going to give you some code that looks like this, kind of some code that's not written the best possible way, where now you have to say like, okay, well, what is, and the question will be, you know, if I write this stuff, what is G of 1 going to return, okay? And you'll want to, you've got to understand these rules, right? You got to understand, if I reassign values inside here, what's it going to do, okay? Students complain, oh, it was very technical and things like that. If you go out and you interview for a job, and they give you a technical interview, it's going to be weird stuff like that. They want to, because that's going to separate people from each other in the interview process. They do care about those rules. All right, so our scoping rules will use the enclosing environment. So if the function is looking for values, it looks in the enclosing environment. So I think we covered that. Okay, and it does support dynamic scoping, but I don't really remember. I just try to keep the default rules there. Okay, is that okay with all of this environment and all this scoping stuff? I hope. Okay, now let's talk about object-oriented programming. Yes, you can learn R and never use any of this object-oriented stuff. It's very possible. Well, okay, I take that back. R is always using object-oriented stuff in the background, and you just don't realize it, okay? And maybe it's okay to go on without fully learning all of these object-oriented rules, but I think it's good to learn, okay? And so we'll do this. You know what? Let me pause, actually. All right, object-oriented programming. Okay, so this chapter, because I've taken this directly from Hadley Wickham's book, is for recognizing and working with R objects in the wild, like as wild as your computer can get. So we have a few object-oriented systems plus the base types. Okay, there's like, yeah, different systems, all right? And the idea behind object-oriented programming, if you've done any other kind of programming, you know, whether it's, you know, C++ or Visual Basic or whatever, there's kind of this idea of a class and a method, okay? And you have objects of a certain type, or what we call class. We group them all together, and we say, oh, okay, this object is of this class, and this object is of this class. And then there are certain actions that are relevant to those classes, and those are called methods, okay? So it's kind of like if in your head we can talk about any kind of vehicle, and we can talk about things, methods that are relevant to the vehicles, like driving and or you know, adding fuel to the vehicle, okay? But it doesn't make sense to talk about those types of methods for a different kind of object, right? If another class of object could be telephones, right? And it doesn't make sense to talk about driving your telephone in the way that we do about vehicles, and then fueling for a telephone, maybe we think about recharging it and things like that. But it's just the idea that you have a certain class of object, and then you have certain actions or methods that are just relevant to those classes, okay? And the way R does its classes and methods is very different from some of these other languages that we're probably accustomed to, okay? Classes are often organized in a hierarchy, and if a method doesn't exist for a child, so if certain action doesn't exist for a child, then the parent's method is used instead, okay? And so in that case, the child inherits behavior from the parent, okay? I copied and pasted this directly from Hadley Wickham's stuff, so that's why you see behavior spelled the New Zealand way, okay? Okay, S3. S3 is kind of R's probably most commonly used object-oriented system, okay? And this is what we call generic function object-oriented programming, okay? Which is very different from, you know, C++ or Java, which is uses what they call message passing object-oriented, okay? And so in, you know, other styles of object-oriented programming, you kind of define the methods that are associated to a class, okay? With generic function object-oriented programming, which is what R uses in S3, you have the function, which we might call a generic, and then we say these are the classes that can use this function, and we kind of tailor those things differently. Okay, so yeah, it says computations are still carried out via methods. A special type of function called a generic function decides which method to call. Okay, it's a very casual system. S3 is a very casual system, and it has no formal definition of classes. Okay, there's other object-oriented systems within R also, and there's S4, and it works very similar to S3, but it's a little bit more formal. You have formal class definitions and special helper functions and whatnot. Okay, and then we have reference classes, which is kind of the newest thing for object-oriented programming in R. And reference class is more similar to other object-oriented systems, other object-oriented programming systems. Okay, it uses the message passing object-oriented systems so that the methods belong to the classes. Okay, not belonging to the functions. Okay, so the other object-oriented systems, the methods belong to the functions. Over here, the methods belong to the classes. Okay. Have people here taken other programming classes and dealt with object-oriented stuff? Like, who has? Okay, some. Okay, only a few. And then who has not dealt with any kind of object-oriented stuff? Okay, so like, thank you for those who participated. We had like 25% participation. So of those who participated, it seemed about half of those, half of you have dealt with object-oriented stuff, and then the other half of you have not. And I don't know if the participation is representative of the class. But so if you've seen object-oriented stuff before, this will feel like really weird. And if you've never seen object-oriented stuff before, this will also feel weird, but for a different reason. Okay. Because it just seems strange. All right, and then there's base types. It's not object-oriented stuff, but the base types in often use C-level code and things like that. So if you don't know, R, the programming language R, is like the underlying code is like written in Fortran and C. Okay, and then a lot of it is built in R on top of all of that. But you know, a lot of those base calculations are done in C, just for speed. Okay, so it says the following sections will describe in system each of these things, starting with base types. Okay, and it says you'll learn to recognize the object-oriented system and how all of this works. Okay, if you want to follow along, I have posted the R Markdown file for today's lecture, and you know, maybe it's relevant for this part. Probably not so much for the environment stuff, but this part it might be relevant. Okay. All right. There's a function called prior that is useful for examining object-oriented properties. But other than that, you will probably never use prior. Okay, I'm just being real here. Unless you're like examining object-oriented stuff, I never use prior. Okay. But all right. So it says underlying every R object is a C structure or struct that describes how the object is stored in memory. The structure includes the contents of the object, the information needed for memory management, and most importantly for this section, a type. And this is the base type of an R object. Base types are not really an object system because only the R core team can create new types. As a result, new base types are added very rarely. Okay. We've already covered the data structures, which the atomic vectors and the integer and logical, all of that stuff. And we determined the base object's base type using type of. Okay, and unfortunately, the naming of base types is not consistent throughout R, and the is function may use different names. So, for example, we have a function. If we ask what is the type of for a function, it will return closure, but then we ask is it a function? We say is function, right? So for whatever reason, they don't call it a function, they call it a closure here. But then we ask if we want to check if it's a function, we say is it a function? Okay, and then a we have primitive functions like the function sum, and if you ask what is sum, okay, if we ask the definition of sum, it will say it's using the primitive function sum, okay, and that's how it adds numbers together. So we don't actually get to see what R is doing when it's adding numbers together. But then if you ask the type of for sum, so it's not going to say it's a closure, it's going to say it's a built-in, but we ask is it a primitive function, and we have to use is it primitive, okay? Okay, we've got mode and storage mode and all of this. Just use type of, that's probably the best way. Functions that behave differently for different base types are almost always written in C, where dispatch occurs using switch statements, okay? Basically, this means, when I use the function sum, okay, which is kind of this primitive function here, or something like that, and if it's going to behave differently for a logical vector versus a integer vector or something like that, and it decides what it's going to do, it might behave differently using something called switch, and that's we'll talk about the dispatch in a moment here. Okay. All right, let's talk about S3. So this is kind of the first object-oriented system, and it's as far as all of the base functions and the stats package that all of your regular functions that you call for, it uses the S3 object-oriented system. Okay, and it's probably the most commonly used one, and it's pretty easy. It's a very minimalistic and informal system. Okay, and it doesn't have a whole lot of rules, and it says most objects that you encounter are S3 objects. There's no simple way to test if an object is an S3 object in base R. The closest you can come is you ask, is it an object? And it will say true. But then you want to ask, is it S4? And you want it to say, no, it's not S4. Okay? Or you can load up prior and use object type. Okay? I don't know how often we need to be checking if something is S3 type, but we could. Okay, so the data frame, right? A data frame, when we create a data frame, and if I say X is 1 through 10 and Y is letters 1 through 10, and Z is going to be 101 through 1, maybe I'll do 110 through 101. Okay, so I've created a data frame here. Whoops, let's save this. Let's clear all of this out. I'll call this df, right? So here's my data frame. No, stupid. You got to use equals when you're creating your data frame. Okay, so I've created my data frame here, and we can ask what is the class for df, and it will say it's a data frame. Okay. And we can ask, is it an object? Is.object df, and it will say true. We can ask, is it S4? And it will say false. Okay. A data frame is an S3 object type. Okay. And we can, if I ask df $y, we have this, and we can ask, what is its class? And it's a factor, okay? So a factor is also an S3 object type, okay? And if we use prior, we can ask object type, and we'll say this is an S3 versus a base type versus a new S3, okay? So here, let me load up library prior. O type, the df, it's an S3, and we can ask O type of the X column is a base type, but the Y column, which is a factor, is S3. Okay, and then so in S3, the methods belong to functions, and those functions are called generic functions or generics. Okay, the methods do not belong to the class. So if you're familiar with object-oriented programming, this is where it's very different. And what we're doing is we use to determine if a function is an S3 generic, you can inspect its source for a call to use method. Okay, if the function has something called use method, that's going to be the function that's going to be for method dispatch. Okay, similar to O-type, prior also provides F-type, which describes the object system. So if I just say what is mean, okay, and I don't use that, it's going to use. It makes a call to use method. Okay, use method is what lets us know that it's a generic function. Okay. All right, and if you type in mean dot, okay, mean dot, we can see some of the different methods that exist. Okay, we've got a mean function that is specific for date type objects, and we have a mean function that's specific for just different types of objects. Okay, but anyway, when we call mean, it's using the function itself is a call to use method, and this indicates to us that it is a generic function. So we have the generic mean function, and then when we ask for the mean function to run, what it's going to do is it says, what kind of object are you giving me? And it's going to say, oh, you're giving me a numeric vector. I'm going to calculate the mean according to this. You're giving me a date object. Now the rules for calculating the mean are different, and I'm going to use a different function there. Okay. All right. So we've got some S3 generics, like some, cbind, don't call use method because they're implemented in C, and so they use dispatch group or dispatch evaluation, and we got internal generics. Okay. So it says, given a class, the job of an S3 generic is to call the right S3 method, and you can recognize S3 methods which look like generic name dot class. Okay, so for example, the date method for the mean generic is called mean dot date. Right, so we have the mean function, but what happens when we call the mean function is that if we give it a date object, it's going to use the mean dot date function or the mean dot date method to figure out what to do with this date object. Okay, so we've got a bunch of different functions called mean, or they're different methods called mean, and they will run based on what type of object is being given it. Okay, and so the use method, this method dispatch, will say, oh, you've given me a date object, I'm going to give you the date method, the mean date method. You've given me a numeric vector, I'm going to give you the method specific for that thing. Okay, we have a whole bunch of different methods for print. Okay, if you do print dot, and you can see all of the different methods that exist for the print function. Okay, and we can see if I just ask what is print, we can also see it's a generic because it makes a call to use method print. So this is the generic print function. Okay, so this is when we use when you name things, I think a lot of things will say don't use the dot in the middle of the name. So for example, there's the function t-test, right? t.test. Okay, the way this is formatted, it seems like it is using the function t for class test. That's what this looks like, but we recognize t-test is to run the student's t-test, but it's It's not to do the transpose function for class test, okay? But it's kind of like been grandfathered in, okay? Or, you know, print.data.frame. So a lot of objects the data frame is called data.frame, but there's, you know, the way it's written here, this is the method. If I say print.data.frame, this is the function there. Okay, that is the function, and this is the commands for how we're supposed to print out a data frame. But the way it looks is it the print function for class data frame? Yes, that's what it is. But it could also be thought of as, is it the print.data function or print.data method for objects of class frame? Okay, which is, you know, could be confusing. But generally, almost everything else, the R will be the generic function dot the class. Okay. So, you know, F-type in prior knows all about this. And we can see, okay, all of the methods associated with the function mean, right? So when we ask for mean, it says use dispatch. This is the default, the generic, and we can say, what are the methods associated with mean, okay? And we can see all of these things. We got mean.date, mean.default, mean.difftime. We can also kind of see them in RStudio. When you type mean dot, it kind of lists them off here, right? We can see all the methods associated with print, of which there are many. There's 198 different print methods, because when we ask for things to be printed out, you know, there are a whole bunch of different object types, right? Because let's think about this. Let's say I have a factor, right? So I say y is going to be a factor where I'm going to take A, B, B. I just do letters. Letter A, letter A, letter B, letter C, letter B. Okay. So y is a factor, right? If we ask what is the type of for a factor, it's integer type, right? And if I did as.integer of y, it's being just the values stored in y are just 1, 1, 2, 3, 2, right? But then when I call y and we print out y, it looks like this, right? It prints out A, B, C, B, and the levels are A, B, C, and there's no quotes, right? It's not printing out a character string, right? If I printed out, if I said this is Z, and I ask what is Z, it prints it with quotes, right? So, and I ask for Y, it's printing out like this. Well, what it's doing is when we call print Y, what it's doing is the print function uses use method print. So it calls the generic print function and it says, oh, what is Y? Y is a factor type. And so what we want to do is we're going to call the function print.factor. And we're going to do the print.factor of Y, and it prints it out this way. Okay? And we can look at print.factor, and this is the commands for print.factor. And we can see where is it doing? Okay. Somewhere in this code, we can see, okay, print out all of this stuff, and then here it's going to print out the levels and things like that. And we don't have to explore this code, but this is the code that gets run that tells our print out the factor this way. If I look at print.default, okay, print.default is kind of the regular old print method, which prints out kind of objects in their base type. So here, if I say use the print.default method on object Y, then it's going to print it out in the default way, where it's going to look at Y, and the regular old Y is an integer type. And so that's what we have here. Okay, and we can try to force it to like print it out as print as a data frame. Okay, and it says, well, I can't, you know, this is what it looks like when you try to print y is a data frame. Okay. And so this is what it's doing. Okay. So we can see all of the you can look at the methods that are also specific for a certain class. So we can see what are the methods that are specific for class factor. We have it. Factor has its own print method. It has its own summary method. It has a whole bunch of these own things. It has its own assignment thing because is there a no, I don't know how to do this. But it has it has its own special assigned functions, methods for its thing. Okay. All right. In S3, if you want to define a class and create an object, it's you just say, okay, we're going to do it, right? So here you can use something called structure, and you can say, I'm going to create something, foo, object foo, and we're going to create, just take a list or whatever you want it to be, and we're going to give it the class FOO, okay? Or you can create the object itself. So here, foo is just an empty list, and then we just assign it, and we say class is this, okay? And all it does is it sets the attribute associated with foo. So let me just clear everything out again. Okay, so foo is just here an empty list, right? So this is what it is. But now I can say class of foo. We're going to call it this, okay? And so what is this? Foo is this, and now it has attributes. Attributes of foo. It says, okay, class foo. And now, if we ask for the class of this thing, it will say that's what it is, okay? And that's it, okay? So now we've created our own object type called object type foo, okay? The class of an object could itself be a vector, okay? And it kind of defines the hierarchy. So if we wanted to say, like if you look at the output of a generalized linear model, it has the class of it is going to be GLM, comma LM, meaning, you know, look at this, look for methods that are specific to GLM, and if you don't see any methods specific to GLM, look at methods specific to LM, and if you don't see anything there, then use the default method there. Okay. A lot of times you have a constructor function, much like factor or data frame, which says, here we're going to take this thing, like if you do factor parentheses around whatever object it is, it's going to turn the stuff that you give it into a factor class, right? So this is the constructor function, and basically here it's going to say, we're going to create a function called foo, which will return objects of class foo. Okay, so this is just a very, very basic function. Okay, it just says check to see if it's numeric, and if it's numeric, then great. Throw that numeric thing into a list and return back an object of class foo, is what it's doing here. Okay, R has no methods or no rules that says you have to do things the right way. So in this case, we can create a linear model, okay? And I'm just going to say, is there a relationship between the log of MPG and the log of displacement using data cars, okay? And then when we create that model and we ask what is the class of that model, it's going to say the model there is LM. And then when we ask for print out the model, it prints it out like this, right? It has its linear model objects have its own special print method that says when you ask for it to print out the model, it's going to print it out in a specific way, right? Because the LM object, if we look at the result of this, let me just create this. The model, oops. We're going to create a linear model object where we are asking for log of MPG as explained by log of displacement. Okay, so what we see is the model itself is a list of 12, but when we print it out, it looks like this. But the type of is a list, right? It's not using the normal way we print out lists, right? If we asked to print it out as a list, we could say print dot, how do we do this? As dot list model. Yeah. Okay, so this is kind of the structure of the model. It's a very big list. It's a list of 12 things, and those lists themselves are recursive and have things within them. But when we just ask print out the results of the model, it's using the method specific to printing out linear model objects. Okay. What is it? Okay. We could turn the model into a data frame, right? And so if I say the class of our model is LM, we could force that and say the class is now data frame. Okay. And now when we do it, okay, and we say print this out, it's going to try to use the data frame method for printing it out. And we don't, it looks like all of our stuff is gone, but it's still in there. It's just the class of this is the wrong thing. Okay. So we could get back these things. Model coefficients are still there, but we just have to say the class is this, and if I print it out, it prints it out back this way. So there's no R doesn't check to make sure you're doing things the right way. It's just kind of loose, and it says, you know, if you want to change the class and say this is a data frame type object or something else, sure, go ahead and do that. Okay, it's not a good idea. All right, it says you can change the type of an object, but you shouldn't. Okay, you know, it just says, you know, don't aim the gun at your foot and pull the trigger. Okay. If you want to create new methods and generics, we can. Okay. So here we could create a new generic function just by making a call to the function use method. So here f is going to be a new generic. Okay. And so what does this do? Okay. So the function for objects of type A, what this function will do is it returns back the string class A. Okay, this is the purpose of this function. So let me pull this up here. Okay, so here I'm creating a generic function. Let me clear out my environment. Creating a generic function called f. And then I'm creating a method called f.a, and this is the function f that is specific for objects of class A. Okay, and all that does is it's going to print out class A. All right, so here I'm going to create a new object of A, by using kind of the structure command, right? So here I have the object A. Whoops. Okay, A is an empty list of class A, and I can ask, what is the class of A? And it does that, right? And so now, notice, I'm going to call the function f on A. I'm not calling f.a, I'm calling the function f itself. The function f itself is just a call to use method. Okay, what use method does is it's going to say, okay, you have given me an object of class A. What do? I am now going to use the method specific for objects of class A, which is f.a. And what does that function do? That function returns back the text class A. Okay. Let me just kind of make up a new thing. Let me see. Here, I'll call this B. This is going to be class B, okay? So B is an empty list, and if we ask what is the class of B, it's going to do this. If I call F on B, what it's going to do is it's going to give back an error. It's going to say, you gave me a class of B, okay, object of class B. When I looked for that function, I didn't see a method specific for objects of class B, okay? And then, so if it doesn't find that method, what it would do is it would use a default method. But then it's going to say, you didn't give me a default method either, okay? And so it's going to complain, right? It's going to say, no applicable method applied to an object of class B, okay? So what I would have to do is I'd have to create a method specific for objects of class B, okay? And I can say f of B, and what it can return is this is not class A, but class B. Okay, and then so now if I run the f on B, it's going to say, it's going to return that. And if I run the same function, but this time an object of class A, it runs the method specific for that thing. So again, the difference between A and B, they are both empty lists, but the class of A is object type A, and the class of B is object type B. We're using the same function. I'm calling f on object A, I'm calling f on object B, but they run different things because it's using the method specific for that thing. Okay? And I can also create a default method, and I would have to call this f.default, and this would say something like, this is not A nor B, so you see default method, okay? So that's f.default, and then if I give f anything else that's not A, B, or C, okay, it's going to say this was not class A, this is not class B, so it's going to run the default method there. Does this kind of make sense what method dispatch is doing? What the function use method? So f itself is a generic function that makes a call to use method. And what this thing does is it says, what class of object are you giving me? You gave me a class A. I'm going to use the method specific for objects of class A. Oh, you gave me B. I'm going to use the method specific for objects of class B. You gave me something else. So I'm not going to use A or B, I'm going to use the default. Okay? And that's what it's doing. Because this way we use the same function call. We're calling everything by calling f. Okay, f of A, f of B, or if I want to call C is we'll call D. This will be class D. Okay, so here D is an empty thing, and if I call D, it recognizes and says it's neither class A nor class B, so you're going to use the default method. Okay, that's how the generics work. Okay, and so that's what this thing does. And then we could, if you wanted to, you could create your own mean function specific for a class, right? So we could have mean.a. This is now going to be a method of the function mean specific for functions of class A. So okay, and so this is what we have. And so now if I call mean on object A, it's going to do this. But mean of object B, you know, B is an empty list, so it's the same as trying to do mean of list. This, okay? It's giving me that, okay? And mean of D, we don't have methods of mean, but this is the same old mean function that we're used to. Okay? It's the same mean function, we're just giving it different things, and it does that. Right? So this is the object-oriented system in R. Is this okay? Does this feel okay, what it's doing? So it has functions that are specific for different object types, and it looks at the class of object you give it, and if it's a generic function, it's going to say, okay, you know, I'm the function mean. People are going to give me all kinds of different objects. So use method's job is to say, okay, you gave me this type of object, I need to run this type of function. Okay, so yeah, use method, yeah, it creates kind of the generic dot that, and so we have different things, and so, okay, I kind of demonstrated this here. So here, f is the generic function. F, we've got a method specific for objects of class A. We also have a default method, okay, which will just say unknown class. And then if we run it, it's going to do that, okay. If we give it inheritance, right? So here we created a new object, and the classes are a vector, and it's gonna, in this case, in the code here, we don't have a method for objects of class B, okay? And so it's gonna say, well, I didn't find that, and then it goes to the next thing. It says, oh, I found a method specific for class A, and it runs that, okay? Whereas if we did something else, it's gonna just fall back to the default. All right, we have this, let's see, group generics are kind of these functions. Don't worry too much about them, okay? Methods themselves are normal R functions. You can call them directly, okay? So you could say, so here, the default method is going to return unknown class, right? But I could, so here I've got A, I've got B, and I've got D. And if I call f of A, I get class A, and if I call f on B, I get that, right? But I could force call the method f.a on object B, right? And what is this going to do? It's going to return class A, okay? Because I'm force calling this method even on an object of the wrong type, okay? Probably not a good idea to do that, but it's possible, okay? That's what we have. Okay, so that's S3. That's S3 methods there. Okay, S4 is a little bit more formal. You have formal definitions for their fields and inheritance and all of this. There's a special operator, the @ sign, for extracting slots or fields from an S4 object. I'm going to kind of blitz through this part a little bit. You can look at all of this stuff. It's complex. Let's see. You can look up, use the function otype to see what type of method it is, and it'll say it's S4. And you know, for example, when you look at maximum likelihood estimation, the results there will be an S4 object. Okay, let's just talk about defining and creating classes with an S4 type. So with S4, you have to define the representation of a class with set class, right? With S3, it was just kind of on the fly. You could just use the function class, throw in a new text string, and it creates a new class of that text string. Here, you have to create something called new class, and then you create a new object using the function new. Okay? An S4 class is going to have a name, and then it's going to have slots, or fields, okay? And then, and it will say it's going to have the class that it inherits from, which will be it contains this class, okay? In slots and contains, you can give it S4 classes or kind of S3 classes, right? S4 classes have other optional properties like a validity method to see if an object is valid, and a prototype that defines default slot values. So we could define slot values that way also. So for example, we can create a new class called a person. Okay, this is a person, and we are going to define that a person object, a class person object, is going to have two fields. It's going to have a name. A person will have a name, and it will have an age, which is going to be numeric. Okay, so objects of class person have two fields: a name, which is a character vector, and an age, which is a numeric vector. So that's what we are defining here. Okay, we can create a new object of class employee. Okay, what is class employee? Well, the class employee has a slot, and that slot is called a boss. All right, so every employee has a boss, okay? And the boss itself has to be of class person, okay? So the boss will be a person, and then employee inherits or contains person, okay? So the employee object itself contains a person and a field that references another object of class person called a boss in this case. Does that make sense? So here I'm creating an object Alice. This is going to be a new object of class person, and the name is Alice and she is 40. Okay? And then I can create a new object called John. John's going to be a person, but it's of class employee, right? So because it contains person, or it inherits from person, we also have to give John a name and an age. Okay, so that's what we have here, but it contains a third field, another field, and this has to reference another object of class person, and so it's going to say boss equal to Alice there. Okay, and so this is the S4 data types, or S4 objects, and here we have to define things more formally using set class. Okay, we can't just on the fly say, oh yeah, this is a class person and this is a class employee. There's formal definition for these things. Question?
Why do you need both the slots equals list boss person as well as the contains person?
So this sets additional fields. So employee, and if we think about what is an employee is a person with a boss, right? Okay, and so we want to say this employee object type contains pretty much all of the fields that belong to a regular person. Okay, so we have to say set class contains equals person. Is that part okay? But we want to give it additional fields. We want to say there's another thing that makes it an employee, and that's the fact that this person is associated with another person called the boss. Okay, and so the slots, when you define slots or fields, you're always giving it a list, okay? And here we're going to say that list is just the object boss, okay? But the boss is of class person, right? So when you define classes and objects, right, you're going to have 3 key properties: a name and a list of slots, okay? And you're going to define the list this way, okay? The slots will be list, and you name these things, which define slot names and permitted classes. And these permitted classes can contain basically S4 classes, S3 classes, or base type classes. So in this case, they're containing base type classes of character and numeric here. And then rather than having to say define all of these things, we're just giving it, we're going to assign the boss to be this object Alice. Does that kind of make sense? Okay. Yeah, it's a lot. It's a lot, okay? S3 is the simple one, okay? And I would say you probably don't have to worry about S4 too much, but I would feel like I would be lying to you if I said, okay, this is the object-oriented system in R, and I don't mention S4 at all. Okay, and S4 is just a lot more formal. Pretty much all other programming languages, the object-oriented system is a lot more formal than R's S3. Okay, but R's S3 works, but allows for things. Okay, and then to access the values in those slots, you use the @ sign. Okay. It's kind of like using the $sign, but it's using the @ sign, or you could use the function slot. Okay, what is in the slot for John and boss? It's the person, an object of class person, named Alice with age 40. Okay, and you can here's some just more examples here for S4. And then with S4, you can define additional methods and generics using stuff like this, except you create a new generic by calling the function setGeneric. Okay, and then and you set a method for the function. Okay, so here we're creating a function called union. Okay, we're going to take the function union, we're going to make it a generic, and then we're going to say it's going to accept objects of data frame, 2 objects, x, y, and both of those have to be of type data frame. Okay, so it's just a little bit more formal. I'm going to kind of skip over this stuff. I will not put S4 on the midterm. I'll say that next week. Okay, you might see S3 and you might see some reference class stuff, but I won't put S4 on the midterm. But it exists, and if you need to reference things, in the future, you have these notes. And Hadley Wickham's book Advanced R really does an excellent job of describing this. Okay. The last is we have reference classes, okay, or RC. This is the newest object-oriented system in R, and this associates methods to the class itself, okay, and this is probably more similar to other object-oriented systems where you have an object of a certain class, and that class has methods associated with it, okay. And an important thing about reference classes is that they are mutable, meaning that you can modify the contents of a reference class object without, which is different from most other things that R does. Okay. Okay, so we're going to create one here. And we're going to create a reference class using the function setReferenceClass. And here, the reference class is account. And then we create a new account by using the function new. Okay, and so this is a little strange, right? Because here I'm creating let me just come over here and clear everything out. And account, I'm going to create a new object called account, and this, all I'm doing is I'm going to do set reference class of type account. Okay, so I've done this, and now account, as soon as I've done this, inherits some methods, such as the method new. Okay, all right, and it says we've created a new object of class account. I didn't define this function new, but as soon as I said set reference class, it gives account the ability to create new objects. Okay, and so actually let's better define what the account reference class is. Okay, so we're going to create, account is going to be a reference class called account, and it's going to have fields, and it has one field, which is going to be the balance, a numeric thing. Okay, so I'm going to say fields is a list, and the one field is called balance, and it's going to contain a numeric object. Okay, and that's it, right? And then so now I'm going to create a new object called A, and this is going to be account, oops, $new, and we're going to set the balance equal to 100. Okay, so there we go. There's A. A is a reference class object of class account. It has one field balance, okay, and I can ask for A.balance 100 in the balance of A. That's it, okay? And I can modify that. I can say, all right, let's change the balance from 100 to 200, okay? And so now if I ask for A has a balance of 200. Is that okay? Huh? All right, this part seems okay. This is where it goes crazy, okay? I am going to do this, okay? I'm going to say B, we're going to assign A to B, okay? So B is also an environment here. I've basically done this. Now watch what happens, okay? If I say, okay, the balance of B, that's 200, okay? Now I'm going to come over here and I'm going to say, okay, what's the balance in A? Also 200. And I'm going to set the balance in A to 0, okay? So the balance in A is 0. What happens if I call B balance? It's also 0, okay? This is very different from probably the other stuff you're used to in R, right? Because if I said C over here is 100, and I'm going to create a copy over here, C is 100, D is 100, and if I change C to 0 and ask for C, C is 0, but D remains 100, right? This is kind of what we're accustomed to. But if we ask for A and B, they are both 0, okay? And that's because they have reference semantics, okay? So this is probably not a good idea to just copy. They are not copied when we do this, okay? So B and A are both pointing to kind of the same thing here, okay? And so for this reason, what we want to do is we would use the command copy rather than just directly referencing. So here B is referencing A, and so all the calls to B are referencing the values in A. If we wanted a copy, then we would use this function copy. So I could say C is A.copy, a copy of A, okay? So A has a balance of 0, C has a balance of 0. And now if I change the balance in A to 100, A has a balance of 100 and C has a balance of 0, okay? So this B would just reference A here. This is a reference class object. So if we did this, B references A, and if we wanted a copy, then we have to use the method copy, okay, which is probably different from what we're accustomed to, because in R, generally when you do a new assignment, it creates a copy right there, okay? Not so with reference class objects. Okay, reference class objects are not useful unless you put in methods, okay? And this time, the methods belong to the class, not the other way around. With the S3 and S4, you set the generic function and you say, we have the method specific for this class, so that when you call the generic function, it's going to look up the appropriate one. Over with reference classes, you have the class, and inside the class, you define the functions inside the classes, and those are the methods there. So here, our reference class is an account with the values balance here, and here inside the account, I am creating a list of methods which have two functions, okay? Two methods, the withdraw method and the deposit method, okay? And withdraw will just take the balance and subtract x from it. Deposit will take the balance and add x from it, okay? Now notice we are using the super assignment here. This is like one of the few times where super assignment is used properly and is what you do. Because the way the reference class works is we see they're actually listed as environments, okay? And so inside here, inside the environment itself is the balance, okay? And then 14 methods, these are kind of your copy and your new methods and things like that, okay? So let me just kind of, let me run that stuff. With my 2 minutes left in class. Okay, so we'll run this. Okay, so now I have I can create a new account called A with a balance of 100, and then I can run the method deposit. Okay, and so the method deposit is a function that takes the balance stored in A, adds 100 to it, and returns that balance back. Okay, and it modifies the value inside balance. So let me just kind of show you what's happening. Is that when I look at A, it's this, and it has the balance here, and it has 16 methods, of which 2 are deposit and withdrawal. And so now when I call a.deposit, and we're going to deposit, let's say 50 to it, remember this function exists inside the object A itself, right? So if I run the function without the double super assignment, it would modify the balance here, but because it's running inside its own little environment here, that value goes away. We want to modify the value inside that environment. So I run it, and then if I ask for A, it now has a 150. Let's see. How do I refresh this? Okay, I don't know why it's not refreshing over here, but okay, there it goes. So so we're modifying the value 150, which is where A itself is treated as an environment there. Okay, it's an environment where functions exist inside the environment, and so in order to modify the values stored in that environment A, we use the super assignment there. Okay, and so here's the examples of this running, and then with reference class objects, you can have it inherit things in from other reference classes. So just like with the S4, you could have it contain another thing. You can say we're going to create a new reference class called no overdraft, and no overdraft is basically it contains everything that an account contains, except the withdrawal function has a check to make sure that you don't withdraw too much money. Okay, and so it changes the withdraw method associated with this. Okay, so that's going to be set reference class, and so we have this, and it works that way. Okay, and that's it. Okay, with reference classes, method dispatch is easy because the methods are associated with the classes. Okay, so we'll end here, and we'll see you guys on Thursday.